today, now. So let's wait an additional minute and then we'll resume. You can follow from there.
No, tienes que sacarlo. Sí, todo, claro.
No, pero no en el router central, papá. Eso te digo.
No.
Yo hablo del router central. Si lo dejo.
Bueno, vamos a comenzar la segunda.
So we're going to start with the second part of the tutorial, and now we'll see what we saw this afternoon when we configured the routers manually, and now we'll see how we can automate the configurations.
Sí, ahí está. Ok. Bueno.
So let's see how the app works. It's called Ansil, and we're going to see how all these apps behave. They enable us to automate things. They're usually used for server-to-server architectures and server-to-device architecture, and sometimes they work as master agent. So, and what these apps allow you to do is to configure things automatically. That is, they manage configurations. All this arises in the so-called development and operation tools, and the concept is continuous and integration and continuous delivery. These are concepts that programmers use, but it's applied in this case. What we typically do is a set of tasks back to back sequentially, so that allows you to change configuration. Most tools you may be familiar with. We're going to use Ansible, but there may be some others that you may know: Chef, Salt, Jenkins, Puppet, CF Engine. There are several more, each with its own characteristics. Sometimes they are similar in other things, some features differ. Here we have a small table comparing Ansible against Chef and Puppet. Remember that the presentation will be available on the website where you have the lab. You can download it in Spanish and Portuguese. So the differences, for instance, here in these three tools, one is in Python, the other in Ruby. The configuration letters are different. YAML for Ansible, and then Chef with Ruby, DSL, and the Puppet with those. They are embedded. The difficulty, the learning difficulty, this is relative, because we could say that Ansible is easier, Chef is intermediate, and Puppet is a bit more advanced or complex. Working architecture, Ansible only has master with no agents. The other two, you need to configure in each device an agent that will be managed by the master. The protocols used to communicate are also different. Some use REST, and Ansible uses SSH and netconf. SSH, and then they are working to use netconf. And then managing configuration, Ansible is push and pull, and the other two are pull only. Now, if we check the architecture of Ansible, the main thing is, well, originally it's a Red Hat project, but they were released from Ansible and they took over another that is called Towers. It's a project that is not open and it's not free. You'll find different elements, and basically what we'll have is a heart, a core with these four elements that are the inventory, the modules, the plugins, and the API sort of apps. Then we are going to have a playbook, that is the original file, and the primary one where we define the main tasks, and then you can have others, but you always start reading this file that's called like playbook. Then you can have configurations, for instance, in a database in the cloud, and we interact with those configurations and we apply them to the hosts or whatever devices we want to administer. The Ansible components are these three. Well, in an hour you won't learn everything about Ansible, but I'll just give you some concepts so that it's easier for you later. We are going to have the control. You need to install it in the nodes that we are going to configure. Then we have the managed nodes that will be the remote hosts where we are going to apply the changes we want to make. And as you just saw, the inventory, it's the list of nodes that we want to administer. So we have a control node. Those are the hosts that we want to administer, and the inventory, that is the list where I'm going to apply the configuration. This is an example where you have the playbook and the inventory, and in that inventory we can define groups. For instance, we may have a group with a host that has certain characteristics. Let's assume that you have servers that run Debian, and then you may have another group of servers that run with another OS or other machines or routers. So we see different machines. So then we can apply a configuration management to a complete group of hosts. What we will see is that we are going to use Secure Shell for all the configuration. Ansible has many artifacts. These artifacts, here mentioning just a brief list. There are many more, but the most important artifacts are this list: playbooks, the chores or tasks that will execute, the variables we're going to use, modules, collections, and templates.
Bien. Sí. Bien. Dale. Ok. Bueno, entonces, uno de los artefactos que tenemos es...
One of the artifacts we have is a playbook. That is a file written in IML, and that has you call to start the execution of the task. It's a list in order of all the tasks, and it contains additional elements that can be other artifacts such as the variables and hosts and complete. You can include complete files. So there are several things that you can have a playbook for, and the idea is that it defines the flow of the tasks that you have to implement for the final goal objective and the configuration for a remote machine. The other artifact is the tasks, and here what it does is to call an Ansible module. Now we see how you do that. But this the important part where we define what we want to do. Sometimes to change the configuration we need several tasks and using several Ansible modules depending on what you want to do. Those tasks, there are two types of tasks. The simple ones, for instance, to scale up a software packet or to copy a configuration file, but others are more complex. Those are the ones that we can put together to, for instance, to deploy a complete infrastructure, for instance, in a service provider. Here we have an example of two tasks, comparing two tasks. These are very simple, and comparing them to what it would be like to install a packet with a Linux server. Here we have a APT, that is Debian, Ubuntu, Shell, others use other Linux. If you look at this, we have a name that defines what you're naming with that task, and as the task gets executed, the screen will show you that that task is being executed. And here, for instance, I'm going to use the APT module that comes with Ansible. So I just say what packet I want to install. The name here refers to the module, not to the task, and the state. I say, for instance, well, install Apache 2. You know, Apache 2, it's a web server. And to install the latest version.
The same if we would do this in a Linux command line, we'll be executing apt install Apache 2. The same can be done installing a Debian package. Here I use the same tool, the same module, and I simply tell which is the .deb file. Now translated into command lines, this would be a dpkg -i and stating where the file is, or an apt install showing where the file is. The variables work in such a way that they make the tasks flexible. These can be generated right at the same moment, or you can change these in a configuration file. And these make the templates more dynamic. There are certain variables in Ansible that cannot be changed and that have to be respected. These are Ansible variables. These are called facts, and others are known as magic variables. I can execute an initial task and bring the information from the device whose configuration I wish to change. These variables, plus those that I have in my system used by Ansible, are those that I cannot change. So if I would like to know what OS my device has or what distribution it has, I can apply a variable and I do the query and it will show me what the Linux distribution is. Now, what does this mean? It means that sometimes I can take into account what version of the operation system or firmware that device has. So based on that, I can make the decision of executing one task or another. The modules are the important part because they define how I'm going to use these tasks. There are two types of modules. You have the core modules, which are the official Ansible modules. These are those that are available. These are the ones that I apply and are also maintained and correct the errors. The extra modules are maintained by the community. And anyone can write an Ansible module and make it available to the community. It will show you how. But that module can be discontinued, so we no longer update it. And at the same time, it has a low priority regarding the reported problems. But you can use modules from the community. There are many that are very well done and are also maintained. As I was saying, the modules are what is transferred to a temporary directory and is then executed depending on the type of remote device. These are executed and then eliminated in one single action. The exit that you will see once we execute these tasks is in a JSON format. And Ansible will somehow process the received data, the data received from that machine, and will show whether errors have been made in what was executed. This is an example of the module collection. This is if I wish to work with the Cisco namespace. There are different models of Cisco operation systems. The one we're going to use, which is similar to the FRR, is Cisco IOS. This module allows me to apply configurations in a similar way. They're not totally identical, so in some cases, some adjustments have to be made. They don't fully coincide with the FRR commands. Those don't fully coincide, but there are some FRR modules that are here in the Ansible community. This is called Galaxy. This is a repository where you can write a module and make this available, or the other way around. You can find modules that were contributed by others and use these. These modules might become collections depending on what has been developed, and they also have a way in which they are written that is respected by the community. This implies that I have to produce the files in such a way that the rest can download these, understand them, and also use them. This is an example with a command from the console. You can look up the modules. For example, those that have to do with FRR. This is a software used for this laboratory as a routing system. Here you have a list of different types of models. Some of these you can use, some do more things, others do less things, but these are available modules. Then we have the templates. The templates are templates in a language called Jinja 2. This enables you to carry out modifications as the task is executed. You can fill in these templates with information from other tasks. This provides a lot of flexibility and also allows you to carry out a large number of tasks and reusing the code used for other tasks and apply it to other devices. Well, it does have a large number of advantages. Jinja 2 is quite complete, and we won't be looking at this in too great detail because we don't have that time. Now, what are the first steps in Ansible? First of all, I have to install Ansible in the central node. I can do this as we saw in the initial slides. It is written in Python. So I use Python, pip. Those who have used Python know that this is an easy way to install the packets. Then I create the inventory, as we saw in the example, group 1, group 2, or also I can enter the IP addresses or the names of the machines that I'm going to configure. I can also verify whether the inventory file is correct. And here there's an issue that is important. Whenever we work with Linux devices, the best thing is to copy the public key in the remote machine. This prevents us from having to use the password. And then I check whether there is secure shell connectivity, and then I send a ping to all the hosts that I defined in my inventory. So that is Ansible on one hand. And now let us have a look at automation. What is the current station of automation? There's several things. It's not as straightforward, and there are a whole series of elements around, so that each developer, each vendor of devices that develops their own software uses the protocol that is more convenient to them. That's a reality. Now, in general, we'll have a brief look at the current status. So we have to bear in mind, among other things, the protocols used, the protocols that allow me to do this automation, the transport protocols used for the connectivity, the data models, the formats for data coding, the programming language that is used for implementation, the applications, and the configuration administrators. This would be a layer model for automation. In other words, I have an application, I have a data model. Normally all coincide that this is Yang. And then we have the protocols that I'm going to use for the purpose of that automation. In some cases, I use netconf. In other cases, I use restconf. And in others, Google NMI. Then we have the format of the information I used. This is not different from the data model. This is information. So there, what I have, it can be XML, it can be JSON. And finally, I have the transport, the protocol I'm going to use. It can be secure shell, it could be HTTPS, HTTP, which is less secure, and then procedures, remote procedures called gRPC, for example. The protocols are the ones we saw just now, the transport protocols, the data models, the data coding formats, and the programming language. So developments have been done in C++, in Python, in Golang, in Ruby, in Rust. So the whole set of programming language applications. You probably have Juniper devices or Cisco or MikroTik of all different types. So there are a whole set of applications, but not all support all. So we are going to have what we just saw, Ansible, Ansible's Puppet, Salt, and Kubernetes, then Paramiko, NetMiko, Python GNMI, Norir, and NetMiko, NetPalm. So in NetMiko, for example, we have one that is used a lot in Juniper, which is PyS, and Arista also has its own Napalm. Then we have configuration managers. So you have software that maintains these configurations compatible. There we have software that is open source, like sysrepo and NetOpia 2 from SESnet, and Cloud Consumer, and then others that you have to pay, ConfD, NSO, and these are from Cisco. And finally, why is this part of the protocols important? Because I'm not only going to use configuration management, but I'm also going to use telemetry. All these protocols allow me to obtain information of the remote device. This information is managed through telemetry. In other words, in one direction, I'm going to configure, and in the other direction, using these protocols, I'm going to obtain information. In other words, the SNMP protocol that is used a lot to obtain information from a device can now not be replaced, but it can have a tool that is a bit more complete and will allow me not only to obtain information but to do configuration. And with telemetry, there are certain statuses in the interface equipments and of the protocols which can provide me with information that there is a change. And this is very valuable because this doesn't imply that I have to doing these questions again and again. Through NetConf, for example, or gRPC, it can inform me if there has been any changes or if an interface has crashed or whatever. So this is the interesting thing of these protocols that are newer. So this would be the end of my presentation, and we now will go back to the laboratory.
No, ahí estoy. Ah, bueno. Bueno, vamos a la página.
So let us now go to the page where we started out. This was https://lacnog/rpki labs. Are you there? I'm going to put it up on the screen because I am no longer in the Zoom and I couldn't reconnect. So there we are. So Nico will now share the page where you accessed. So there you have the guide, the script. So in this page, you will access the interconnection the practice guide of automation with Ansible. It's BGPQ4. So you select practice guide for automation with Ansible and BGP Q4. So if you'll recall your passwords, remember your passwords?
TLabs Training.
.tlabs.training. Raro, no entiendo.
No, debe haber algo mal. Dale, dale, compartila. Ahí está, ya está.
Como decía Santiago, para
So, as Santiago was saying, for this part of the laboratory, you're going to need a password to access with the automation from a script that you'll be running on the client side. So you need a password to access the router. The password for each of your routers is different. So what we're going to do now is going to let you know how to access the list of all the passwords. You have to look up the one that corresponds to your group and use that to what Santiago will be explaining now. So to access the password list, go to the start page when you wrote your username and your password. Otherwise, access the address lacnic43.te-labs training. And once you are in that address, if you pay attention, this initial link was for the letter of the practice, this link up here. This is for the script of the practice. This second link is a password list. So click there, open, and you have another screen with the list of all the passwords. So look up that corresponds to your group. If you're group number 10, group number 10 has this password, is everything that you see after the comma. All that, including the equal sign at the end, that is a password for group number 10. So look up your password, and that is a password you have to use in the configuration that Santiago will be explaining right now. If you need any assistance, please let us know and we'll give you a hand. Anyone needs help? Anyone needs assistance? I'll go there and help you. So while Nico helps you out, let us continue.
Bueno, estamos todos en...
So we're all in the practice page of Ansible and BGP Q4.
Si alguien necesita ayuda, levante la mano.
Bueno, a ver. Bien, vamos a seguir. Entonces, tenemos el...
So we have the same scenario, the same topology as we'd seen so far. And the first step is installing the Ansible collection we're going to use. Can you see it there?
Vamos a ejecutar este comando.
So we're going to use this command.
Bueno, en mi caso me dice que ya está instalado porque
So in this case, they're telling me it's installed. So you're going to receive a new message telling you that it was installed successfully. Please let us know if you were unable to complete this step. So we go back to practice, to the drill. And now what we'll do is to clone the repository containing all the tasks described in Ansible so that we can execute them. So we go to the second command, that is cloning this repository. In my case, I did it. I've already done it, so now it's your turn.
A ver. No, sigue igual. Sí, pero no sé qué. Bueno, se verá así. Ahí está.
Los que están en el control de la pantalla, no sé si ven que ahí
So I don't know whether there you see a black box. Please, those with a projector, do you think you can remove it? So let's try and remove that dark part. So let's do the following. We'll go to this directory.
¿Ya dónde? Toda la pantalla, sí. ¿Esto? Y ya está minimizado.
Pero ¿por qué no compartís solo la...
Hola. Ahora lo que podemos, vamos a continuar. Vamos a ejecutar el comando.
So let's execute this command tree Ansible. And there it shows us all the components, all the files. Where it says backup, those are tests that you will completing and that it will get filled. Now it's empty. Then you have the host file, that is the inventory, the iOS file that contains all the tasks we're going to run, the playbook that indicates the start of the tasks, a template, and then we're going to see how it works in J2, and then the directories. So let's leave this. And I'll tell you what you have to do. Please change the host file, and where you have the X, put your group number.
Pueden editarlo con nano, con B. Bien. Seguimos. En el
So let's go on in the variables file that is called vars ios.yml. You have to change 3 fields. Where it says password, Ansible password, where these X's are, you have to replace it for your own password that Nico just showed you.
So that password is in a simple inverted comma. And that same file, where you have the variable mySN, where you have 2 X's, you put the number of your group. And in the router ID, where you have the X, also write the group number. So each one is going to execute the Ansible tasks on your own router. So just a remark for those who have arrived now, for those who are a bit lost, is something that you have to execute from your client. Remember this, the schematic representation, you have to execute this following this guide. If you have any doubts, please raise your hand and we can assist you. So let us start then with the task. Anyone has any issues? Over there.
¿Quién necesitaba ayuda?
Who was needing assistance? Anyone else? So let us go back and explain this once again. In the host file, you simply change the X for the group number. And in the vars file IOSYML, enter your password and replace the X's for the group number. So while Sylvia and Nicolas help you, we will go on for the sake of time. So, as we don't have that much time, let us now start executing the task. The first task is T0. This task, you can look at this afterwards. This is what we saw, the name, the module, and the parameters that this module requires in order to complete the action we wish to carry out. That within that task. So the T0 task includes several tasks. So what this will do is to take us to the router, to the beginning of the laboratory today. So we're going to lose everything that we did. So let's execute this. Ansible playbook. You have this in the guide. And you can do a show run in the router if you wish. So you see we configured our PKI and the prefix list, the route maps, all the BGP. And we take that to 0. The command is the one you have in the guide. The one you have here. So I'm going to take you from the console to the guide, and you just execute that simply with that. There you have different messages that are added so that this serves as a guide. Then we use show run, and we see that the router, we see that that hasn't anything else configured. Now, the details of the task, if we have time, we'll have a look at that. Otherwise, we'll be here, around here, all week. So if you need anything special, if you should comment on something, wish to ask a question, you will find us during the event. But the idea is that this automation part is something that we do, and if we have time, we'll look at the details. So now, what we're going to do, for the sake of time, is to execute several tasks at the same time. These tasks will be T1, which is configuring our PKI. Let us try with this one alone to see that the router starts to be configured. So we execute Ansible playbook and put -T1, the same command, but we change the T. Now we put show run, task T1 configured RPKI. Now we have the configuration lines for RPKI at the end of the show run. Am I going too fast? Raise your hand if you already got this far with the playbook. Let's wait a bit then. All right, let us repeat what we just did. We run the task T0 as we saw in the guide over here. And that task deletes everything that we had configured in the first part. And the router is practically as it was right at the beginning, as it was before we began today. Now with the T1 task, to see how this works, this task configures RPKI. But because we don't have that much time, let us now execute the tasks T2, T3, T4, and T5. So with all these tasks, what we're going to do is to take the router to what it was prior to deleting everything. So we include the task list of the task files, and each task file contains several tasks. And if you wish, you can have a look at the backup directory, because each task that we execute saves this configuration. In other words, if we are in a development environment and we have some errors, we can go back and check the configuration. Normally, Ansible, whenever a task is executed, what it does is that it shows us what was changed and which are the tasks that are OK. In this case, all are in green, all are OK. These 5 tasks, or 4, 2, 3, 4, and 5, 17 were executed from those files, and there were 12 changes in the router. Let us now have a look at the PGP4. We're going to take information from the LACNIC IRR. This information can be viewed with a whois. This is something that you don't have, in the guide. Just a second.
Bueno, en este caso estamos usando, esto lo vieron hoy.
So in this case, and this is something that you saw earlier today with Erica and Guillermo this morning when they showed you how to do a query with the IRR. What we're going to do now is to do a query with the owner. The owner is Nicolas in this case, who kindly created a couple of registries for the purpose of this laboratory. So you'll find different types of registers in the IRR. This one is a registry maintainer. And what we're going to do now is this one that we prepared for the purpose of this lab. So we're now going to use an AS set with this number over here, with this name. And this AS set shows me that I'm going to allow the announcement of prefixes from these autonomous systems, which are from 65,000 through to 65,005. If we execute this with Whois, filtering this information, what we will see then is that it shows me the autonomous systems that I'm going to apply in the routing filters with the AS paths. As part of the task, there is a command called BGPQ4. This, for different router models, allows you to generate the AS paths or the AS paths that I wish to filter. It is quite easy to use, and it also allows us to save a lot of time, because writing all those filters is quite complex with regular expressions. BGPQ4 is for several routers. It's free, and you can download it or execute it depending on the type of router, even up to MikroTik. So what we're going to do is to execute a command, as you can see over here. I'm calling this object called VSet, and it's going to show me what I'm going to apply in the router. But it turns out that this is for Cisco. So the task of Ansible is to modify this. Now let us go back to our router and put show BGP. We have a whole set of routes that were generated from different autonomous systems that are provided by the border router. And we still have the route hijack, that is the last prefix you see over here, that is announced by the 65,002. What we're going to do then is, with task number 6, we're going to generate these AS paths in order to filter them. And in task number 7, we're going to apply this. This can be done in just one single step, but I'm showing this so that you can see how this is done. So let's go back to this task to execute this, and only task 6. So it finished. Now we put show run in our router, and we're going to see what was modified. These access lists were added with the AS path, and it only accepts announcements coming from the autonomous system 65,000 to 65,005. And on the other hand, this is something that I have to apply in a route map. We're going to we created a route map that we have down here. This is called permit sum ASN, and this matches this AS path that I wish to filter. We're going to run show BGP. We have all the routes over here that are announced by the border router, and now very rapidly we execute task number 7. If we have a look at show BGP, we have only one prefix. This is where the question comes up. What must we do in order to remove this prefix as well? What do you think we should do? We eliminated everything that was not originated by the tutors routers, but we still have this hijacked route. We applied the filter, but nevertheless, that route, because it belongs to one of the tutors, it is still alive. So it is included in the routing table. So what can we do to eliminate this route? I don't know whether there are any prizes for this. Are there any prizes? Nope. No prizes.
Volvamos a la configuración del router.
So let's go back to the configuration of the router. What happened? We changed something. We applied a roadmap that filtered all the prefixes not originated by the tutors by AS 65000 to 65005. But there's something else. the route map. So, what do you think that could be? There's a brave man there. Could you use the mic? Remember that there are several mics on the aisles. And we do have gifts. Good afternoon. Fernando from Peru. We would have to add the network filter to remove the invalid routes. Exactly. And how would you do that? By adding the route map so as to enable only the valid ones. It's near. You're close. If I add that route map, I remove this one. Could you repeat the question? What is missing? You told me that you had to filter the apply RFKI because it's an invalid. So we use an DNSSEC that allows me to filter and to leave only the prefixes originated by the autonomous systems of the tutors. So when applying this, as we applied it, we lost the RPKI, the filter. But you're in the good track. So to remove and to keep only the invalid, and now to add what will enable me to filter the invalid ones. So to do the route map with the two filters. Yes, we applied it there. Good. There you get this price. So let's apply task 8. That, as Fernando said, Fernando Peru, we change the route map that we're going to use, and we see that reflected in the configuration. In this case, once again we use the route map of RPKI and we add the two matches to match what we wanted to filter out and the RPKIs if they are valid. And now there's another task, that is to apply it in the neighbor. So with task 9, it changes it back to a route map that is RPKI, but it filters both things. So before doing that, let's see whether it works. Remember, show BHP, remember that we had a prefix that was I, invalid. And now, with task 9, no, 8 again, error, typo error. So now let's go back to the router. We don't have anything. So we did something to show how we could take information of the RIR to only leave what we want to receive from neighbors or a certain ASN that we want, and we filter out all the invalid prefixes of the route that was hijacked through RPKI.
Bueno, no sé si hay preguntas.
So I don't know whether there are any questions.
En la semana, así que el que quiera preguntarnos algo de Ansible o de todo lo que...
So if you want to learn more about Ansible, or if you have any question about what we did with Sylvia and Nicolas, you can approach us. We didn't have too much time, but you have all the info. And Nico, until when can they have the machines running to access? Well, you can use it these days. The lab will be available until when? Until Thursday. Until Thursday. All right, so you can practice because the lab is going to be active.
So that you can take your time to do this, because you can do it at your own pace. You will have the guide, so you can do this later or tomorrow. So if there are no more questions, I give the floor to Guillermo, who will be closing this laboratory. Guillermo, before you close, let me tell everyone that we'll be around all week. You have our contact information. We can give you our email addresses, and if you have any questions, any comments, these are welcome. You can see us around. Guillermo, I have a question. Are we going to... okay, I didn't say anything. So we will be around. If you have any questions, we're around all week, so we can continue discussing these topics. And if anyone wishes to have something sweet from Mexico, because you stayed on right to the end, I have some to hand out. We'd like to thank the 3 facilitators for this lab. It's incredible that we finished on time, 10 minutes ahead of time. But we knew we had the social event today, really had to finish on time. So let's give them a round of applause. Thank you very much to those who stayed on. And for those of us who are in the room, we will have the social event tonight. This will be in the restaurant Coco Bamboo. And the address is in the program. We have transport available for guests staying at the Holiday Inn as from 7:15 p.m. Let me remind you that you need to take your credentials, the badge, and tomorrow we'll start at 8:30 local time, 11:30 UTC for the opening of the event, and the panel challenges